Woohoo! I'm live. This is Math 75, Mathematical Analysis for Business. This is 6.3. This is where stuff gets real. We're going to talk about the future value of annuities. We're going to sing a song. Maybe you're welcome to sing along. The first thing we got to talk about is what the heck is an annuity? This is where the singing is going to come in. This is a financial instrument, which sounds so fancy, comprised of a series of regular means, consistent, equally spaced payments, either in exchange for or in place of a lump sum. So, what's an example? Well, if you win the lottery, a lot of people know you can either have the money right up front or you can choose to win $50,000 a year for 20 years. That's an annuity. The other one that you may have heard is those ads where the people are all singing. There's a singing bus one. They're all singing, "I want my money now." And there are various versions of this. This is what happens when you win a court case a lot of times. Instead of giving you all the money up front, they give you a little bit of the money every year. The reason for this is it's less expensive for them to do it that way. If they give you a little bit of money every year, then it is worth less than if you got all the money up front. So that's an annuity. There is something really interesting called a perpetuity. Now, a perpetuity would be something like a pension, and instead of going for, say, 5 or 10 years, a perpetuity would pay you every year or every month for the rest of your life, in which case there's some interesting gambling going on. Because, for example, if you look at Social Security, that is a kind of perpetuity. They promise to give you a certain amount of money every month, but they're kind of hoping that you, well, let's be honest, die quickly, because then they spend less money. So same thing happens with all sorts of pensions. So there's a lot of stuff we can talk about with annuities. We're just going to basically talk about one kind of annuity, and that kind, the easiest kind, is when you're depositing money. So if you deposit money into an account, like a savings account, regularly every month, this is going to be a type of annuity. This is an annuity where you're putting money into the bank and you're saving up for something. We want to know what the future value is. So I want to know the value of an asset at a certain time in the future, not how much it's worth now, but how much it would be worth in the future. So by the end of it, how much money do we have saved up? So that's what we're looking for. So we're looking at a slightly different thing than what, like the lump sum of the lottery would be the value today. I want to know how much you will have saved up. So in order to do this, I've come up with an example, a very simple example. I want to invest $100 at the end of every year at 10%. So $100, I'm going to put $100 into account, and I'm going to put it at the end of every year. I'm going to try to earn 10% over the next 5 years. Okay, pretty straightforward. So I'm saving up for something. To calculate this, I keep track of each deposit separately. Now, I know this is kind of surprising, and some people are like, no, that doesn't work. It totally does work. That's the really cool thing. So each deposit, here's the first deposit, is right here in this row is the first deposit. Here's the second deposit at the end of the second year, the third deposit, the fourth deposit, and the fifth deposit. So each deposit gets its own row. So let's take a look at what happens. At the end of the first year, I deposit $100. So at the end of the first year, I have $100 saved up. At the end of the second year, two things happen. I deposit a new money, so new $100, and the old $100 that had been in my account for a year now earns 1.10. Now, what's going on there? Well, it doesn't earn that. It earns 10%, but it is equal to 100 times 1.10. Why is that? Let me remind you. Future value equals the principal plus the interest, or P times 1 plus RT. But in our case, T, if it's annual, T equals 1. So S equals P times the quantity 1 plus R. So that's P times 1 plus 0.10, because that's how much we're earning, is 10% per year. Okay, so each year that the money is in, it earns, you multiply times 1.10 to get the new value. So this $100 has been in for 1 year, so it earns one of those. Okay, third year, I make the third deposit. Now, the second year's deposit has been in for 1 year, so it earns that. It's up to there. And then the first year's actually been in for 2 years. So now we're starting to get somewhere interesting. We're up to compound interest, annual compound interest, which means if it's been in for 2 years, the exponent is 2. Next year, this stuff has been in for 3 years, so we've got a cubed. This has been in for 2 years. This has been in for 1. This is brand new. Fifth year, $100 goes in. This one's been in for 1 year, 2 years, 3 years, 4 years. And what I want to do is I want to add all of these. At any given time, this is how much money I have at the end of the first, end of the second, end of the third, end of the fourth. Here we go, end of the fifth. So that's what I've got right there. That's that total that I wrote out for you. 100 plus 100 times 1.1 plus 100 times 1.1 squared plus 100 times 1.1 cubed and 100 times 1.1 to the fourth. It turns out that this is something called a geometric series. Each one has a 100, and then each one has a 1.1 to a different power. So this probably looks a little bit like a polynomial, right? We've got x, x squared, x cubed, x to the fourth, but it's a little bit different than that, but not too far off. And it turns out the sum of this, all of this added together using it, there's something called a geometric series, and this is the formula to find the sum. So the formula is this bad boy, 100 times the quantity 1.10 to the fifth minus 1 all over 0.10. So this is a formula, and I'm going to calculate it on my calculator. I want to point out that we're going to have to start getting a little more exotic with our calculator now. I've got 100. I'm going to multiply times parenthesis. I need to get all of this together in the numerator. 1.10. Let's be honest, you could just write 1.1 raised to the fifth power. You got to find your fifth power key. And the thing is, you can go directly into the minus 1. That's the amazing thing. Close the parenthesis. And to be honest, I always hit equals whenever I'm done with the numerator, which is what I've done there. I set equals so I can set it. Then I'm going to do divided by 0.10. Okay. Handy dandy calculator. You guys see it? Not really. There we go. 100 times parenthesis 1.10 raised to the fifth power. Now, when you raise it to the fifth power, I've got an old calculator. It doesn't do anything, but some calculators actually put you up in the fifth power. It actually lifts you up into a superscript. Make sure you come back down, which usually means a right arrow to come back down, or else this minus 1 is going to be up in the exponent. So be very careful. Close the parenthesis and equals. There's my numerator divided by 0.10, and I get $610.51. Okay, how many payments did I make on this? I paid 100, 200, 300, 400, 500. So the payments, total payments are $500. So my interest is $110.51. Now the question is, why didn't I earn more? If I have $500 deposited and I earn 10% a year, I should be earning like $50 a year. So why did I make so little interest? And the answer is because I'm not depositing $500 at the beginning. The first year, After the first year into the second year, I only have $100 deposited. Second year into the third year, I've got these 200s deposited, but they're not earning the same amount of interest because this one's brand new. Third year, 300, 400, 500. So this is like saving up. This is a way to calculate what happens when you don't have the money right at the beginning. A lot of our formulas require you to have all the money at the beginning. This one's going to allow you to put in a little bit at a time. Okay. So here is the formula. Dun, dun, dun. I gotta be careful not to do that. YouTube thinks I'm swearing. I'm not swearing, YouTube. I'm just making scary music. The future value of an annuity is this formula, which we just played with. It comes from the geometric series. Notice that I've got a new letter. I've got R. R is the investment amount each period. And I believe that R stands for repeated or repeat payment. I think that's what it stands for. That's what it makes sense as, so I think of it that way. So it's the payment that you make over and over again. Again, this is 6.3. We are no longer in the world where we just put some money in and we're done. This is the world where we're going to put a little bit in every year or every month or every week, however it works. N is the number of periods, just like before. N is still going to be M times T, just like before. And I is still going to be R over M. So these things are still holding from when we were doing the compound interest. Now, there is a new concept, a future value of an annuity due. An annuity due refers to the fact that these annuities are paid at the beginning of the period. This is more like when you pay rent or when you have to pay back your credit card or when you pay the mortgage. If you pay at the beginning of the period, then something interesting happens. Compare and contrast. What's the difference between these two parts of the formula? You're right. The big difference is this right here. So if it's an annuity due, hopefully I didn't smear too much. Smeared a little bit, but not too much. If it's an annuity due, then it has an additional 1 point plus I there. Let's talk about why. Back in our picture, if it's at the beginning of the year, we move everything back one period. And then everything makes a little bit extra interest. That was at the end of the first year is at the beginning, so it gets a whole year of extra interest. So the whole thing gets, this is the extra period of interest. Okay, so this is going to be a long one. We are going to do the twin problem. The twin problem that we're about to do is really famous. Sorry, you can't see the extra period worth of interest right there. The twin problem is really famous. The twin problem is totally part of an agenda I have, which is to try to convince you to start considering saving now. And I know as I speak, financially, things are looking a little rough. We may, in fact, be going into a recession right now, and it may be very hard to save up. And I know people are losing their jobs and all sorts of uncertainty. And I don't mean to disrespect anyone, but if you do have a little extra money, consider saving it. Consider getting it into a money market account. Consider getting it into a CD if you can. Just start depositing a little money if you can afford it, anything you can afford. And if you can't afford anything, that's fine. But if you can, start investing it now. And so I'm going to show you this problem where it's two twins. And weirdly enough, the way the book does it, we start with twin 2. So here we go with twin 2. And then we'll get to twin 1. So twin 2 is 29 years old. He wants to deposit $2,000 per year. So the repeated payment is $2,000. And we're doing per year. makes things easier. Of course, we could do it per month as well. In an account paying 10%, now that's the 10% is the R, right? It's the interest rate per year. And because we're looking at per year, our M is 1, right? It's annual. Remember, M is how many periods per year. So between these two, with the R is 10% and the M is 1, we divide R by M to get I, our interest rate per period. And then we're also told that he's going to do this for 36 years. So T equals 36. And I'll remind you that M times T, which in this case is 1 times 36, which is 36, is the N, the total number of periods. Okay, so I know you can't see the formula that's up above, so I'm going to rewrite it. S equals R times 1 plus I to the N minus 1 all over I. Now on finals, what I usually do is give a sheet of formulas. So I'll have a sheet of formulas that you'll be able to look at. I won't tell you which formula is for which, but I will have all the correct formulas on, and so you'll be able to find it. The way you'll recognize this one is you'll recognize that we're looking for S is future value and R is repeated payments. Okay. So this is 2,000 times the quantity 1 plus 0, 1, 0 to the 36th power minus 1 all over 0.10. So that's 2,000 times 1.1 to the 36 minus 1 all over 0.10. Okay, so let's calculate this together, or I'm going to calculate. I don't know if you're going to calculate it. Okay, so it's 2,000. And remember, I'm old, so I put in a lot. Oh, you can't see that. That's right under the light. Sorry about that. That's 2,000. I'm going to put in a lot of extra multiplications times parenthesis, right? We got to get those parentheses in. Parenthesis 1.1 raised to 36 minus 1. And again, if you've got a fancy one and you put it up in the exponent for 36, bring it back down to do the minus 1, close parenthesis, equals, divided by 0.1, and I get a really nice amount of money. I don't think I'm going to complain if I ended up with this much money. Of course, it's after 36 years, so there'll be a certain amount of inflation. So it's, it's hard to know exactly what this will be worth. Just under 600,000. Okay, $598,253.61. Now, how much money did he actually invest? Let's look at this. The total of his payments, $2,000 per year for 36 years. So the total payments is $2,000. Can you see that? Oh, you can't. I've gone off the side. Sorry about that. Times 36 equals 72,000, right? This is not nothing. Coming up with $2,000 per year, not easy. And this is kind of a bizarro world where he can find an investment worth 10%. Again, there's probably something sketchy happening here because 10% is pretty high. Right now, you would have to have a really good broker to be making consistently 10% on the stock market. It can be done right now, especially if you've got no fear of heights and lows. You can do it on the spot market with oil, but man, you have to have a stomach of steel for that right now. Currently, let me put it in perspective because I don't know when you'll be watching this. Currently, the oil markets for June, and June is the front month right now, but May, just a week ago, it crashed, and at its low point, oil cost negative $40 a barrel. So it was kind of bonkers. But anytime you've got big swings like that, you can be making money. And I guarantee you someone did. Someone made a lot of money. I don't know who those people are. If I did, I would call them up and say, hey, you want to go get a sandwich? You're paying. Okay, so back to this twin number 2. Twin number 2 made $600,000 on $72,000 worth of investments. That's not bad. Now let's go to twin 1. They are fraternal twins. Twin number 1 has a rough time. So she starts early and deposits $2,000 in an account paying 10% every year. So R is 10%. M is annual. So it's 1. Starting from the moment she's 21. Now, here's the interesting thing. I don't know if you caught it. Twin number 2 was like going to school or something. So he started when he was 29. So twin number 1 is starting when she's 21. So when they're both 21, she's starting this. And she deposits $2,000 in an account, 10%. And the thing is she can only afford to do this for 8 years. Okay, so I is 10%. And N, which is 1 times 8, is 8. Okay, so let's see how much money she earns from this. So yet again, we've got a repeated payment. $2,000. 1 plus 10%. Can you see this? Yes. To the 8th power. And if you calculate, which I did this ahead of time, you get 22871.7762 and some other things, which is approximately $22,871.78. So she had to stop early. And so after 8 years, she's only got $22,000. Then this money just sits in her account for another 36 years. So her total payments, she pays for 8 years times, so it's 8 times 2,000. So she just paid a total of $16,000. And in the beginning, it looks like she doesn't do very well because she put up $16,000 and it only has $22,000 to show for it. But that's only in the first 8 years. Now let's look what happens. She leaves this in the account for an additional 36 years. So it's at 10% annually for 36 years. Now here's the hard part. It is, sorry about that. Again, I was having a party without inviting you, sorry. It is really hard for me to know which of these two numbers they used. Because in some settings, we would round this first and then do the next part. And in some settings, we'd keep this one. I'm going to go ahead, since my calculator, my calculator doesn't already have it. I'm going to go ahead and use the unrounded version. Okay. There will be a slight discrepancy between the two, but I'm going to use the unrounded version. So let me put that in very quickly. 1.1 raised to the 0.1. Okay, there we go. So I've got that amount, which is this one, and use that. And then here, if she's just going to leave it there, this is going to be a different formula. This is going to be our old friend, that guy, because she is not doing any more payments. So something happened and she couldn't make any more payments, and so she just lets it ride. So the future value is going to be this $22,871.7762 ... 1 plus the interest rate is 10% per year. and then it'll be to the 36th because there are 36 years. So let's go ahead and calculate that. And I know this is the longest video ever. This is almost half an hour video. I'm so sorry. These problems just take forever, don't they? So I've got this amount still in my calculator from before, and I'm going to multiply times 1.1 raised to the 36. Right, so you can't quite see it. This is the last answer. It says ants. That's why answer. So the previous answer times 1.1 to the 36th power. You ready? Seven oh seven oh 27 9109. Oops, that. Ooh, I'm a little addicted to this stuff. I find myself making mistakes just so I can use it. It's so fun. Okay. So what the heck just happened? What happened is I'm really tired. So, twin 1 at 21, she started doing her deposits right here. 2000, 2000, 2000, 2000, wait, 1, 2, 3, 4, 5, 6, 7, 8, something like that, up until the time she's 29. And then she lets it just ride for 36 years until they are 65. Twin 2 did nothing, started at 29 and put in deposits, right? So twin 1 did all the deposits and just let it ride. Twin 2 did all the deposits later. With the head start that twin 1 had, she made more money. I'm sorry, my cat is on the other one. Than twin number 2. Twin number 2 made just under 600,000 with how much a deposit? 72,000. Twin 1 made, again, her total payments, she only made the 8 initial payments for 16,000. But because she started before he did, she made more money than he did. So she made over 700,000 on $16,000, whereas he deposited, what was it, 72,000 and had just under 600,000. So what is my agenda? My agenda is that time is on your side if you're young, and if you can even deposit. No, I know normal human beings can't deposit at 10%. But you can put a few dollars away here and there. And if you can, it's really worth it. Try to get yourself into a savings account and try to deposit some money if you can at all afford it. Okay, enough of the proselytizing. We are almost done. Man, this is a long section. So the last thing is I wanted to point out what a sinking fund is. It's there's a lot of jargon in business. A sinking fund are periodic deposits that will produce a sum on a specified date, usually to save up for a purchase. So it's like when a company does a layaway plan. If you know that you're going to have to buy a new building, for example, or if you know that you're going to owe a bunch of taxes, or you know you're going to have to spend money on a new piece of equipment, what you do is you put a little bit aside every week, you invest it, and that way you will be able to pay off the debt when you're done. Okay, we did it. Just under 29 minutes. Woohoo! Math on, guys. Math on. Happy capitalism.